Hey, what's up? This is Václav here. If you watch my channel, you know that I like to play with small displays. You know, it's cool to have everything controlled from a website, but when I'm, for example, in the garden and I want to start the irrigation, or when I'm leaving the house and I want to check whether there will be some trash collection, going to the computer or taking out my phone and starting Home Assistant, it might not be the easiest thing. I mean, if I want to just do something, I can use voice control, but often I'd like to just check the state of things and then possibly take an action based on that. So I make small HMIs for that, and I share them on a GitHub, and I make videos about that, and they are quite popular. I made a sprinkler controller, a weather station, and I have a small display next to the entrance that shows state of different things around the house. Recently, I have extended that with the details about the energy management. It's quite useful. For all of these projects, I used Nextion displays. They are simple and affordable, and they are supported in ESPHome, so I love them. But they are controlled through UART, so this is the TX, RX, ground, and 5 volts. So you need some kind of microcontroller to control them, and I typically use some variant of Sonoff for that. But if you don't have one available, adding one just to control display makes no sense. It's complicated, you have no use for the Sonoff, and you would have to make some complicated enclosure for it. Then there are plenty of HMIs that are made for Raspberry Pi. They usually have an HDMI interface, and they're great, but they need Raspberry Pi. And to have Raspberry Pi just to control display, that doesn't make sense for me either. So then I have discovered this Elecrow display. It has ESP32 built inside this, and it has the touch display. It's powered from USB-C or a battery. It has quite rigid body, so you don't have to make a complicated enclosure for it, like I did for the weather station. And it has a number of interfaces, like the UART, IC2, digital and analog, and they even make variant with small camera on top, so you can make face recognition. So it looks like a perfect choice for what I need. The only question I have is how difficult it will be to interface with the Home Assistant. The graphic uses an open source LVGL graphics library. This is quite nicely looking SquareLine Studio to do the design. They support Arduino and MicroPython, but you know what? Lately I'd like to avoid programming, and I try to do things either with a native integration or with ESPHome. The microprocessor is ESP32, and the display is ILI 9488 chip. Both are supported in ESPHome. Not sure about the touch interface, but you can add custom components, so let's see. Right, so I'm in the ESPHome script editor, and I'm looking at an empty screen. And why is that, you might ask? Because when you start ESPHome, there's like a wizard. It'll ask you a couple of questions. What is the board you use and some of the common settings, and it'll pre-configure the device for you. And this might be good if you're configuring your first device, but this is not my case. I have a number of devices, a couple of dozens, and many of them, they are very similar one to the other. So what I do instead is I kind of created my own templates, and I copy the settings or snippets of codes from one to the other. So let me show you what I use. There's always this section ESPHome. This is mandatory for all the ESPHome devices. There's a name which always has to be there. And then there are two optional fields, friendly name, which I always like to use. If you look at the ESPHome dashboard, it shows you what the device is about. You're not limited to the naming of the devices. And then there is a comment, which is also optional, but I always use it to show either what type of device I'm dealing with or what the device actually does. And as you can see, this section doesn't have any actual values because it's using substitutions, which is what I was talking about. I have this ESPHome generic section that I use across all of my devices, and then I have this part of substitutions on top of each of the files where I have the configuration that is specific for each device. So this is the ESPHome. Then I always use some packages, so the configuration of the Wi-Fi, over-the-air updates, and the Home Assistant API. And I have them actually defined in a separate file, so all the settings are kept in this common directory in api.yaml, ota.yaml, or wifi.yaml. The beauty of that is if I want to change something on the API or Wi-Fi, for example, I can change it in this one single file, and then I can recompile all the devices, and I don't have to update every single device configuration file. And those are using substitutions as well, again, in case I want to use one device separately, so I have the passwords and the secrets kept in the secret file, so I don't have them in the script. Then I always have the logger, so I can see what the device does, I can debug. And then there is a section ESP32, because this device is using ESP32 microcontroller. And this one is specific for the device. Each of the ESP32 devices, they have a mandatory field for the type of board. If you would look at the Platformio website, it will show you, and there is really, I have a filter here, but if I would unfilter it, there is a 14 pages of different boards, and each of them have a different board time. And I need to use the right board that is on my device for it to compile properly. This display is using ESP32 S3 chip. And this is a little bit complicated. There is still 2 pages of those, and I have to choose the right one. And it has 16 meg of flash, so if I know that, then this is limited to a couple of devices. So hopefully it'll be one of those. And I can use this to copy the board ID from here actually. So I didn't know which one it is because the actual Elecrow display isn't there. So I contacted the manufacturer and they told me that the ESP32 S3 box is the one which is quite similar to that. So this is what I have used, and I have configured that in here. And then optionally you can select different frameworks, either Arduino or ESP-IDF. For the S3 it is recommended to use the ESP-IDF. So this is the definition of the minimum firmware that will build for this device and connect to Wi-Fi, connect to Home Assistant. I'm not gonna configure the display or any of the other components on the device, because once I get this working, I can keep adding piece by piece, and if something doesn't work, I can focus on that, get it working, and then move on to the next part. So I'll start with that. I will connect the display with the USB-C to my computer. And then I'm going to hold the reset button, push the boot button, and then release the reset button, still keeping the boot button, and then I'm going to release the boot button. So now the device is in the upload mode, and I can do install, and it's plugged into this computer, and I will select this port in here, and I will say connect, and then it tells me that the configuration doesn't match the platform of the connected device. So that means that the board we have chosen is not the correct one. So what we'll need to do is we need to check some of those other boxes. I know it was 16 meg of flash, so I will try some of the others and see if some of them work. And I'm not gonna bother you with that, so I'll pause it here and I'll come back when I tried them all. So none of them worked, so this is gonna change our plans slightly. So I'm not going to configure it in the ESPHome, and well, I will see if I can get the device working through the Arduino. Okay, so I did not expect that. On the ESPHome website, they say that the ESP32 S3 is experimental, so I suppose it will be fixed over the time. But you know what, I'm actually starting to look forward to refresh my memory with Arduino. They have a quite nice demos, and the SquareLine Studio seems to generate the Arduino project source files anyhow. So I will hopefully just generate it, and then it'll be just a matter of adding Wi-Fi and MQTT and putting some logic behind. So let's see. Right, and so what I'm gonna do is I'm gonna start with the SquareLine Studio. So this is a application that is free for use. There is a trial version, And when I saw it, I thought like, well then, this is the end. But if you look at the website actually, then in the licenses, they basically have a personal license for free. So for our creators, this is all we need. There is a limitation of a number of screens, but 5 is enough. 50 widgets, well, not great, but let's see. Components, this is something that will be a little bit limiting. So I'll probably try to design without using components. And it's not for commercial use, but I think it'll do. So let's get back to the SquareLine. So I still have a trial, so I will continue with that. And I have created this page in here, so I'm not gonna bother you with designing it from scratch. There is plenty of tutorials for SquareLine. If you're interested, you can look at those. But essentially you have different widgets that you can put on the screen. The way it works is you would like to build this hierarchy. So you would like to start with a screen. So I have 2 screens. There's one for settings, which I haven't finished yet. And then there is one with the control panel. And on the screen, I put different panels. And then I put different widgets, so buttons and text, on those panels. And as you can see, the label is actually a child of this button as well. So the beauty of that is if I would move this, all the content within the panel moves with it. And the other beautiful thing about it is it actually has this smart positioning. It looks almost like a CSS. It's using a flex layout, and all of those buttons in there, they actually align to top mid. So the only thing is I specify they are 17% high and 100% wide, and that's all I need to do. Then I also defined custom background color for the default state and then for the checked state. So you can change specific values in those style sheets. And then the other thing that I have done is there is a font manager. So I've added a couple of fonts in here that I'm using on the screen. And then also I have a couple of PNG files that I use for those buttons as well, because I think they are easier to read than text. So this is the screen I have designed. Just briefly, let me explain you what I have in here. The purpose of the screen is to be in the garage, so I can have on the right side overview what's going on currently with the solar plant, how much power I'm producing by the plant, am I importing or exporting from the battery, same thing with the grid, what is the consumption of the house, and what is the state of charge of the house and of the battery. So it's like an information just for me. I don't have to look it up anywhere. And then the main part is those buttons. So if you have watched my video for power management, you know that for the cars I work with different smart modes, so it knows how to charge the car. And so I have those modes: fast, off, available, and scheduled. I'm not going to explain them here. If you want to know what they are, just watch the previous video. I think it's really great. And then there is the auto, when those modes are automatically selected by the Home Assistant based on a number of things, based on day of a week, time of a day, and so on. So I have a choice, either say it's auto and then the Home Assistant will decide automatically how to charge the car and what to do with the house, or I can pick manually one of those modes and then it'll be in there. So for example, if I come home and I'd like to charge the car now, maximum power, I don't care about the automations, I will just say fast and it'll start charging the car immediately. And then I have this box on the bottom showing the currently selected mode by the automation. So this is the screen I have created. Nothing fancy, nothing too graphic, but hey, it works for me. It's functional. So all I need to do now is to export it to the Arduino project. So first I'm going to export it and say create template project. So I'm going to do it. It's going to ask me to select the directory where I'd like to put it. So I select directory, I'll call it generated. So it's going to be the generated file, and I say open, and I'll export it there. Export succeeded. So I do this thing once, and then I will export the UI files, and this is done as well. And I need to do that anytime I change anything on the layout and I'd like to update the project. I will then just say export the UI files, and it'll refresh all of those source code. And what it does is it will create this SquareLine project within the directory we have selected, and then it's going to put there the libraries we will need. There's a README file which is going to tell you what you need to do, and then there is the UI directory with all the code it has generated. So if you look at that, there is the project file, the INO, which is the basic Arduino file with the setup and with the loop. And then there is the UI.c file where you have all of those widgets created, and what it does is it'll actually generate a C code which generates a lot of those components. So what we can actually do is we can open this UI.ino in Arduino, and we can upload it to the device right away, and it should load to the device, even though it'll just show the interface the same way as if I would push this play button here. So there is this sort of demo trial, so I can do that. As you see, it doesn't do anything. If I push the buttons, it doesn't do anything. There is no logic, there is no values in here, because it doesn't communicate obviously with the Home Assistant. So this is something I need to add in here. And then some of the other files you see, it generates for the fonts. For each font it'll generate this kind of source code file, and the same thing for the images. So for the images it will generate the source code. I don't need to do anything with those, I'll just keep them in there. So looking at that, if I were to try this with the ESPHome, it will be, I guess, quite a lot of work. So it's probably a good thing that we went the Arduino route. And it looks like the project is almost ready for deployment. So the only thing we need to do is we need to add the communication with the Home Assistant, and we need to add some of the logic for the buttons to switch. So what I'm going to do is I'm going to copy all of that to a separate directory. I'd like to keep this one the way it is, and I will copy it to a directory called Display Garage. So all of those files I copied in here, and I have added parts of it for the communication with the Home Assistant. So let me show you. So I'll open it in the Arduino IDE. And each Arduino code has at least two functions. One of them is setup, and what I've done here is I have just added the configuration of the Wi-Fi with the SSID and password that I'm connecting, waiting for it to connect it. And the second function is the loop that defines what the microcontroller does once it is initiated. Then the communication. Initially I thought I'm gonna use MQTT. Arduino has this quite popular library PubSub, which I thought I'm gonna use. But then I realized that in Home Assistant, for the buttons I use input selects. For all of the power flows I use the integration with GoodV or Skoda Car. None of them use MQTT. I would have to have an automation to regularly republish all the values to MQTT on any value change. And I thought there must be a better way. So what I decided to do, I decided to use the Home Assistant native REST APIs, and I wrote two functions. One is to get entity state and set entity state. They both use the Arduino standard HTTP client library. Basically what it does, there is this IP address of the Home Assistant. It's locally on my network, so I can use that. And then the URL is API/states, and after that there is the entity ID of the sensor I want. And then what I need to do is I need to add the authorization header. So there is the bearer token, which is one of those long-lived access tokens you can actually generate in the Home Assistant. So you will just generate one here, and you create token, it'll generate piece of code, something like that, and you just take it and you copy it and then you use it in your code. So I'm gonna delete this test one, and each application has a unique one. It'll only show one, so you have to remember it somewhere, and if you lose it, you can always generate a new one. So for the Display Garage, this is what I have created in here, and this is what I have stored somewhere in the secrets. And then all it does is HTTP get and it'll get the response and it'll parse it because it'll get it in the JSON and it'll get the state value and it'll return it. Then I have a similar one I have created for the set state, and that one is using actually a put method of the API. Other than that, it's the same. So I get the state as a parameter of the function, I serialize it in JSON, and then I post it. So these are the two basic functions. They don't do much error handling, but I suppose it'll do for me. So this is what I use for the communication. And then I have changed the UI code. So first I have created a function that is setting the button states. And what it does is it will go through all the buttons. So there are 5 buttons. And when the button corresponds to the mode I'd like to set it to, then I will change the state of the button to a checked state. And if it's not, then I will actually clear the state check, so it'll be unchecked. And the other thing I do is I will then call this function we just saw to send the new state to Home Assistant over the API. So that's that. And then I have another one which is actually going through all the fields with all the values, and so it's getting all the states for all the photovoltaic power and battery state of charge and whatnot, and it's setting the text label with the format. For the power I'm adding W like watts, and for the percentages I'm adding percentage. So this is that. And then I have this piece of code here, and what I actually decided to have a different picture for when the battery is charging or discharging, and when I'm importing and exporting the energy. Maybe you saw it in here. So this is the button for exporting energy when the energy flows to the grid, and this is the button for importing energy, so the energy comes from the grid. And I like to have a green color for export because this is good for me, and for import it's red. And for the battery, if I charge it, I set it green, and if I discharge it, I have a neutral white color. So that's that. And then I'm going through the button states. And so I'm here checking whether the mode has changed, and if it did, I'm going to update the buttons as well. And then there's this button even handler that is called when a button on a display is pressed, and what it does is it'll set the corresponding mode. And here is the control screen initialization. So this is pretty much the code that was generated by the SquareLine Studio. So I admit it's not as easy as ESPHome, because I had to remember how to program in C code again. I didn't do it for like 5 or 6 years, so I had to get back to it again, fighting with it a little bit. Took me a day or so, but then once you get into it, it's actually quite nice and very flexible. You can do pretty much anything with it. So now that I have the code done, I can just hit upload. I will compile the code and upload it to the device. I have selected that the device is connected on this USB port. So what I need to do is put it in the boot mode again, and it will connect to the device and it will upload it. So now it's saying it's uploaded, and I can reset it. So I'll hit the reset button and look at the display. And it shows the display and it shows the values from the Home Assistant. And if I push any of the buttons, it'll actually pretty nicely react and change the mode and do exactly what I wanted. Now, let me make a disclaimer here. If you think that the way it works is that I just wrote the code the way I explained that, and I hit the upload and it was done and it was working, well, it's not the case. I spent about 3 days doing it. But if I would make a video 3 days long, you wouldn't watch it, would you? Initially, it took me about 1 day just to load the screen. There was lots of trial and error. You know, embedded programming is not as simple as writing automations in Home Assistant. If you have anything wrong, it's very difficult to debug and to find where the problem is. In most cases, it will just reboot, and you would have to sort of debug it in putting different messages in different parts of the code, trying to figure out where it crashed and why, unless you have a hardware debugger, which I think most of us don't. But I think the SquareLine Studio helps a lot, and I progressed in the steps. So first I wanted to get the screen to show without any controls, and then I was gradually adding different functionalities. So first the button logic, and then at the end I added the communication with Home Assistant. I tried with the MQTT first, but at the end it was getting a little bit too heavy and a little bit too complicated. So I actually scrubbed the MQTT and I went for the API communication, which is what I use. Okay, so it turned out quite nicely at the end. What do you think? So now I'd like to mount it to the wall. The display has a quite solid acrylic body with 2 screws in the back. So my plan is to 3D print very simple French Cleat that I will screw to the back of the display and then slot it in a frame that I will screw on the wall to create a thin plate under the display. On their website, they have all the dimensions I need. Display is 106 by 66 millimeters, and it has 2 M3 threads 40 millimeters apart. So that should be simple. I'm gonna use Blender to do that. Yes, it is an overkill, but I know it, and I'm not gonna learn a new program just to do this simple plate. So let's quickly do that. This is not a Blender tutorial, so I'm not gonna walk you through the whole thing, but just a quick time lapse. I'm gonna start from a basic cube. I'm gonna give it the dimensions based on the website. Then I'm gonna use add-on to add the bolts, and I'm gonna choose M3. I'm going to configure the head to be countersink, and then I'm gonna configure shank that I'm gonna use as a cutter. Then I'm gonna duplicate it because the mount is gonna have 2 parts for the cleat and for the piece mounted on the wall, and each will need its holes. And I'll rotate the second one so it's facing the wall. Now I'm gonna focus on the cleat. It's gonna be symmetrical, so I'm gonna delete the right half and use the mirror modifier so I don't have to do everything twice. And then I'm gonna resize it based on the bolt position from both sides, from the side and from the bottom. And then make the sides in 45 degrees angle to create the cleat. And then I'm gonna duplicate it because I'm gonna use the second part as a cutter for the second part. And back to the cleat, I'm gonna use Boolean operations to cut the holes for the bolts. Now back to the piece mounted on the wall, I'm going to use Boolean again to create holes for the bolts. Again, I'm gonna use mirror modifier, and then I'm going to use the copy of the cleat to cut the hole in this piece. So now I have 2 parts. One is the actual cleat and one is the mount that's going to be attached to the wall. Then I'm going to use solidify to create like a 0.2 millimeters gap between the 2 pieces so they can actually slide in. And then I'm going to use also cutters from the top and the bottom to make sure there is a gap between the display and the plate, and as well between the wall and the cleat. Right, so now it's done, so let's export it to an STL file. Then I can go to the slicer, organize the pieces on the bed, generate the G-code for the 3D printer, and we can print. Once mounted, I screwed the cleat to the display, and let's test if the other part is gonna slide in. And it does very nicely, it creates a seamless frame. So let's put it on the wall. I like to put it next to the charger cable, and conveniently I have a UPS there for the Home Assistant with a USB socket. So I'm gonna just put it on the wall, mark the position, drill the holes, install the anchors, mount the frame, and then just slide the display in, and it fits there very nicely. Alright, so this was a bit more difficult than I expected. In the beginning I even thought I would give up. But after starting some simple demos, I had to relearn Arduino, I had to learn how this LGVL works. But after that, it was actually quite simple. In fact, I started liking it quite a lot. I might even do some more. Now, would I recommend this to you? Well, it depends. If you're familiar with Arduino or MicroPython, then yes, it's actually quite fun. The library is quite similar to the web style sheets, and you have a full control of the display from the microcontroller, Unlike the Nextion, where you have to do the HMI design in the PC editor and then you upload it to display, and then from the microcontroller you just set the object properties, here you can do much more. But if you do not know Arduino, then I wouldn't recommend that. For the same reason, I'm not even sharing the source code, because if you don't know Arduino, then it'll be useless, and if you do, then you don't need this. Even if you're willing to learn, I'd start with some simple project first, and then if you like it, you might take it from there. Alright, so that's been it. Let me know if you like it, and if you don't, I'm sure you will let me know as well. And I'll see you in the next one. Bye.